Professor Yang-Hui He,
one of the pioneers of AI-assisted discovery.
It's ridiculous because the computer doesn't want to do anything. It doesn't have wants.
But then on the other hand,
After playing around in the early hours of the morning with some machine learning, Professor Yang-Hui He sensed its potential in computing topological invariant. He's now spreading the message about the potential that AI has in the future of math. And today, he's playing around with the world's first interactive course builder with integrated methods of formal verification. He's taking lessons in a course that was built by just uploading the table of contents of his book into the course builder and giving it the preface as well for context. As you'll see in the video, I think he was quite shocked by how all we did was give the course builder the table of contents of his book. And by the end, well, let's just say he had some ideas about how he was going to write the problems in his next book.
right, okay.
So we just gave it the table of contents of your book and said, I'm an undergrad, don't know much algebraic geometry, but know the prerequisites.
Right. Oh, well, actually, so maybe it's better that I benchmark this against my own book, so at least I know.
Yeah.
Instead of, because, if I try to learn model theory, I wouldn't know what the answer is right or wrong anyway. Maybe I just continue with this. Oh, okay, well, yeah. Oh, I see. Oh, you build this up. I see. Oh, wow, you're ready.
You don't have to start at session one.
Session one. How was this? So you literally took the text of this and then it...
No, so it's just, I just uploaded the table of contents so you can see what it's doing. Gave it a bit of context like you would give in a preface.
Right. Wow. And then it'll train you somehow. Like you would take it being tutored by your agent. Oh yeah, back to that thing. Oh yeah, I did. Okay. Session one. Okay, I see. We begin with geometric tradition. Tracing boundary. Where do these words even come from? Is this just? But how is even like? This is not in the table of contents. How is it filling in all this information?
So, Grok is what seeds everything based on what you tell it you want to learn in the course. In each lesson, there's a plan of roughly how it should evolve to get to the content. But then, if you as a student were to type in, "Oh, I'm a bit rusty on this," or "How does it relate to this?" or "Here's my understanding, is it correct?" then the way it teaches you, the examples it brings in, the emphasis it places on things changes, but still so that it teaches you all the content within the session.
So I could type like my message, like, let's zoom in on that curve you gave, that curve example you gave. Would it know that there's only, I think it's only referred to once. Would it know to go on that curve? I even typed it wrong. Let's zoom in on that curve. Yeah.
Oh, you can send it.
Typo is fine. Okay, yeah.
What we put a lot of emphasis on was working out what are the main pillars of tutoring and then splitting that up into a system. So much testing of, as a student, what are you trying to get with your message? Verification in the sense of another AI looking at it with feedback. It goes through a loop. And then we've integrated formal verification, but it's obviously a work in progress in terms of how much it
really
can...
I mean, you build lean into it.
Yeah, so if you go to at the bottom of the message, there was the purple...
Yes, really? Wow, that's amazing. So this is something that GPT doesn't have.
At the moment, the verifications you can get, unless it's sort of year 1 or 2 undergrad, it really struggles.
I see, because Project Xena has all of undergraduate math. Project Xena is the lean project to incorporate all of the sentences of the undergraduate math curriculum.
Oh, okay. So we use vectorized a lot of mathlib, and then we use RAG. So basically it says for each claim it extracts from the tutor's message. It says, we think the proof might look like this, so it would be really helpful to know if this was in mathlib, and then tries to find it really quickly.
That's amazing, because mathlib is a pain. I'm not an expert at all in mathlib, even though you must know Tim Gowers.
Yeah.
Do you interact with him? His entourage.
No.
I guess he doesn't. He's so I chat a lot with his former student, Bhavik Mehta, who was an undergrad and then part 3 and then...
Yeah, I think I've used his notes before.
So Bhavik is an awesome guy, really nice guy, and then he's in London right now as the postdoc of Kevin Buzzard, and he was on the Alpha Proof team during his, he was an intern that was involved in Alpha Proof, Alpha Geo and Alpha Geo Proof. So he's been teaching me lean, and it's not easy. I mean, this is a nightmare,
Yeah.
but it's just kind of nice that you can just your system interacts with lean, right? Which is
And
amazing.
the nice thing is that I think in your talk at the Royal Institute, you said you feel like AI is on the cusp of natural language too.
Absolutely, absolutely. Yeah, I mean, we don't know when it is going to be, but Bhavik really thinks that it's going to be 5-10 years time before we have auto formalization. I mean, that's more or less reliable. But you're kind of already doing this here.
So using like having it interact with Mathlib has helped, but it's the sort of things it gets caught up on still feel quite elementary a lot of the time in terms of I look at it and think, why have you done
That's
that?
amazing. What would I need to do to make like I just don't know and I need assumption? But when Lean doesn't verify it or say things like it'll be like question mark and put it in red.
So that one, you see it says 3 out of 4. That means that one of the claims wasn't able to be turned into something which...
I see.
It's the affine variety one function.
Affine variety, okay. So this statement was unable to be formalized in Lean at the moment. Why?
So that will be an error with the system getting confused with something. What we're working on at the moment is actually if what it's finding from Mathlib isn't that relevant, but it's still looking at it, then it confuses it a lot more. So it's working out when to show what's similar.
Very interesting. Very interesting. Yeah. Okay. There we go. Let's zoom in on the affine curve. Great. I mentioned this is a classic example of a smooth affine curve. To be precise, the full elliptic curve is actually in its projective closure. Okay, we'll get a moment. First, note that the curve is defined by a single polynomial equation. To check smoothness, it has no single computer partial derivatives. Great. That seems so far seems good. There's no singular points. However, the affine curve is not compact. That's good. And then you can projectivize, so equivalently does this. And now check that's point of infinity. Moreover, it has a trivial comeback in a one-dimensional Glavier manifold. Okay. This illustration occurring theme.
Yeah.
Okay, that's very nice that you can do this. Yep, and yeah, so this looks all good, and it's verified 4-4. Okay.
Oh, so you got a full proof, that top one. It's got a green tick.
Now, would sense, but proof meaning that you trust everything that's been said here.
As in, so it's gone through a team which has the message goes through a team which extracts claims. Even sort of, it's quite hard to get everything because there are lots of implicit claims like, if the tutor's talking about manifolds and it says an example of this is this, then there's a claim that that's a manifold. But then
I see. So I mean, this is already a much better improvement of ChatGPT because ChatGPT can just hallucinate anything.
But then
and there's no way to check its.
Yeah.
Right.
But then each claim goes through the process with interacting with Mathlib, trying to get turned into formal language, and then it actually gets sent to a server which hosts Lean, and then is actually verified.
Yeah. Oh, nice.
But
right.
The claims you see there aren't verifying. They're verifying what the tutor is saying because it's student-facing ultimately. But it wouldn't.
So you just say something like, by team you mean agents?
Yeah.
Okay, not human team.
That's why it's so slow.
Let me just say something like, something just wrong. And say like, I think that curve, this curve would have genus 4. So this is just the wrong statement, which is great. So would it then like?
Yeah, I guess
start correcting me and stuff, and then make verifiable statement.
Yeah, and it's designed to pick up on really subtle errors from the student as well.
I see.
And what we do as well is once you finish the session, you can see there's that notes and feedback button, and it will generate proper formatted notes for everything you talked about in the examples. Right. And it will give you some pretty brutal feedback.
It's just such a shame it takes so long because, by then,
But-
the student will be like so tired waiting.
But
You'll fall asleep.
the nice thing is that as models get better, you just put them in, and so they'll get faster and faster.
Okay.
But this is, I'm sure you're aware that skepticism is quite a hurdle to overcome. So
Yeah, of course.
quality is.
And then you want to ultimately turn this into a company, or you maybe already have a company.
Yeah, thinking hard about what does the role of AI in math look like in 5-10 years. I'd like to ask you about the Birch test and interpretability. Well, firstly, I wonder how, in terms of these sort of leaps you see mathematicians making in logic and progress, do you think they're how special do you think the brain of a mathematician is, or do you think it's really quite just a few box of tricks, basic reasoning, which is just surrounded by loads of material, which is difficult?
Interesting. Well, I certainly think there are some among us, like people like Terence Tao or Gauss, who have certainly more bags of reasoning ability than us mortal.
I have becoming more and more of the belief that actually the human reasoning system isn't so special, and it can be reduced to like a handful of patterns.
I think so far it will be very difficult to get something interpretable just by looking at say if I have a complicated neural network that has completely replicated my input output, whether it's a formula or some theorem or proof. If there's another network that could analyze this and make sense out of that network, then we would have a sort of an auto-interpretability thing. But I think that's quite difficult. I don't foresee that happening in any time soon. I think math this AI for math will go faster than this problem, because this is like a really fine-tuned AI, neural network problem that we don't have the advanced techniques to get info out of neural networks. Well, we're still at a fairly low level. One of the projects I'm involved with is just to take neural networks, complicated neural networks, and just trying to reduce depth and width sequentially until it becomes nonsense. And where does that phase transition begin? But this is done purely from the point of view of statistical physics. There's nothing more than just looking at just basically phase transitions.
Interesting.
And it would be hard to get meaningful mathematical statements out of that.
And
I'm still thinking. Wow.
apologies.
No, but you say that this will get faster and faster, right, as the system learns more.
Yeah, and it has slowed down since we've deployed.
No, it's awesome to see like a system that has lean coupled to it.
Thanks. It's building this whole thing has been like.
Yeah, no, this is really incredible.
It has been like sort of smashing my head against the wall. But what got me through it was you said when you were with your initials, this might work for topological invariance, but you sort of don't really think it will. But then maybe you have something which suggests that there's potential.
Exactly.
From that point to actually having something useful, how did that look?
Yeah, that actually, I think that's probably the hardest part, because I kind of abandoned that direction. The early experiments that I was doing, here's a neural network that really predicts the data really, really well, but so what? I couldn't even think of a way where one could extrapolate interpretable result from that. So that's why I went that's what partly inspired this Birch test. It's like, how do you even get something like this? For the memorization conjectures, we kind of lucked out in the sense that we were able to inch out interpretable stuff, but it's very hard. There we go. So all right, continue. Yes. Okay. Good. It keeps trying. Okay. Good. Great. Oh, so that is correct. All right. So it knows not correct. That's fine. Okay, that's such a good. So this is all correct, and so it was able to catch my mistake.
Those are the sheets. So
wow! Which I don't have.
And it will look at your session to generate
Holy
appropriate
shit.
questions.
Wow. Damn. This will be very useful. Because I just wrote a book with a new book with CUP called the ADE Patterns in Math. And one of the things that CUP wanted was questions. And I was like, oh my God, I'm not going to be able to write that.
Well, here you go. Problem solved.
Here, I should have met you earlier. Would it give solutions to these problem sheets?
So at the moment, it gives hints. And we're about to release a feature which is like talking to the tutor.
Oh, that's epic. So, but how does he even know that? I mean, how do you get the information of this into this? Just from contents?
Yes, it's just a table of contents. And then I guess Grok has ingested a lot.
Wow.
But
I'm curious now because I want to try my new book ADE. And how do I set this up myself? Just want to try it, like the system. That's crazy. And then generate questions. I mean, of course, it'll take a while for it to generate. And
well, just use this account, the details that I sent you earlier.
That's amazing. Wow, that would be really, really useful, right? Question 1. Compute the gene. Oh yeah, that's a great question. Consider the affine curve. Find the degree of the projective line. Assume the projective closure is smooth. Compute its genus. Explain why the curve. Question 3 is a smooth plane curve to D. Oh yeah. And then wow. I was able to find, because it doesn't have this book right in it. It's able to search whatever the internet, search its database, whatever it's been pre-trained on, and get keywords from the thing from the book table of contents, and then start, inferencing all of this. Wow.
So
that's a feature I can do this myself.
So Grok was we were building this for ages, and the models was very unsatisfactory. Like, we would see flashes of quality, but consistency wasn't there. Yeah. And so our architecture was getting more and more sophisticated, trying to compensate. And then when Grok came out, it was like, whoa, like finally. And then we had to sort of descale some architecture because we were doing too much.
Why do you have Gauss? Why is this Gauss with apostrophe?
Oh, so that's so Gauss with one S is the name of our system. For legal reasons.
Oh, see, that's cute.
And then Gauss is.
But why not Gauss with two, the original Gauss?
Well, I was concerned that there's maybe some.
Oh, I see. Fine.
Some legal issues there, but.
Fine.
I think he's quite old.
But he's dead. It's not like his family's going to sue.
Yeah, but I think I've seen Einstein on adverts on the telly, right? So someone owns that.
That's right. Yes. That's right.
You'll probably quite like the books section as well.
My book tree. Yeah. Explore book trees. Yeah.
So these are all other users. So if you just clicked on view tree.
Oh, these are your friends up there or something.
Yeah, these are just users on the site.
Okay.
So that's their book tree. Right. And then this is what's used to find people that have similar reading.
Including geometry in mathematical whatever.
Professor, thank you so much for your time.
No, thank you. This is amazing. I'll definitely explore. I mean, we can keep continuing in touch by email. That's amazing.
This AI journey has been very exciting for me, but it's also frustrating because.
No, I'm really glad that the young generation, like people like you, are really engaged in this. And this is amazing. This is the first time I've seen something engaged with Lean, even a chatbot that has Lean in it.
I guess my final question to you is, you mentioned at the end of your talk that there's a lack of funding. How do you think you go about changing that and changing people's perception?
I think it's a lack of funding. There's no lack of funding globally. There's a lack of funding in this country. Somehow, there's something I love about this country is that it's kind of slow because you can imagine Oxford and Cambridge colleges, they're slow to, but there's some charm to that. And mathematicians are also a very conservative bunch. I mean, in general, but. I think this will change very quickly, very, very rapidly. I think the moment that, I think we need something. We need to show a big major open conjecture being solved by this kind of games we play. Then, not necessarily one of the Millennium ones, but just one of these, Terence Tao says, I solved this problem and using this. He's already beginning to tweet about it, but they're kind of baby things. But if there's a serious problem that's been solved in this kind of interaction, then all mathematicians will just jump into this. I think we need to market it well. We need to sell it.
Hopefully that happens soon.
I hope so. I think probably the next few years, I think that will happen.
Great. Well, thank you so much for your
Also,
time.
thank you. This is amazing. I'm going to keep on playing with it. Awesome.